This video is for Lecture 7, the Intro to Electrical. We're going to take a look at the electrical slides as well as some electrical terms. Let's start off with the slides. So for electrical systems, you have your main electrical service transformers. This is where the electricity comes in from the utility, your power company, and gets distributed into your building, either your house or your business. You have a couple different ways here. You have a pole-mounted transformer. So you'll usually see this with smaller buildings or residential houses, or you'll have pad-mounted transformers, which these are usually larger. Say strip malls with multiple businesses or larger buildings will have maybe 2 or 3 of these of really big transformers outside feeding electricity in. Next, we have electrical meters. So you've probably seen these at your house. These are what measure the amount of electricity are coming into the building. This is how the electric company knows how much to charge you. If it's just your house, you'll see one piece like this. This setup is either for apartment buildings or like a business center that's got multiple tenants, or they all pay their own bill separately. Next, we have electrical CT box, CT can, or CT enclosure. And these are just part of the electrical distribution systems that are used for metering purposes. So the service comes in from underneath and gets fed up into these bars here. And these bars are connected to the meter, and it reads how much electricity flows across and goes into the building here. So these wires are all leading into the building, into your distribution panel boards. Next, we have a disconnect switch. A disconnect switch is a way to turn off electricity going to a device. You pull this handle down and it will create a physical separation here so the electricity stops flowing. So then you can safely work on a piece of equipment. You can think of it essentially like a big light switch. Pull it down and it turns the electricity off. Next is electrical wireway. So that is any of these long, narrow boxes where you can make wire connections in here, and you can close it off to safely keep people, to keep people safe and from getting electrocuted. Next is a main switchboard. So the main switchboard is like a beefed up panel board. You have the main electrical service come and feed into your unit here, and then it goes out and distributes electricity to smaller panel boards, to different floors, to different areas. This is the main distribution piece of equipment. Next, you have panel boards. So this is, you've probably seen these in your house. This is where all of the breakers are stored. So if you open these doors, you'll see a bunch of little switches, and those go to different pieces of equipment, to different runs of plugs, washer, dryer, microwave. Basically, it's the next step down from your main switchboard. So your main switchboard will feed the panel boards here, and then the panel boards will go out and feed the individual circuits. Next, you have a ground bus bar. Ground bus bars are these big copper pieces, and what these do is these prevent short circuits from jumping to people, hopefully. These are usually tied into a building structural component or structural steel or plumbing system, because a lot of times they use metal pipes in buildings. And this, if there's a short circuit in a building, then it can safely pass to the ground bus bar, and then from the ground bus bar to the actual earth. Next, we have your lighting system. Lighting systems consist of multiple pieces. You have your lights. This is a typical 2x4 light that you'll see in offices and schools and whatnot. This is your controls. So nowadays there's lots of you got to have lots of dimming controls and occupancy controls. This is what's called a bug eye. So this is like an emergency light fixture. So designers have to be aware of the path of egress, which is the way out of a building in case of emergency. The emergency lights either have to be on a generator or battery backup. This could be on a wall, and if all the lights went out under emergency conditions, these would come on, and they'd have a battery in it, and they'd light the light the walkway on the path of egress. And then you have your exit signs here. At any location, you should be able to see an exit sign to be able to safely exit a building, even if you're not familiar with the area. Next, we have fire alarm equipment. So there's three main pieces to fire alarm equipments. First would be this lower right one. This is the fire alarm control panel. So this is in an area on the first floor that the firefighters will know exactly where this is located, and they can come in here and manually control either fire alarms, or they can plug a phone in here to make general announcements, or if there's a two-way communication devices in stairwells, then they'll be able to communicate with them. Then you have initiating devices, so that is both this lower right one and lower left one and upper right picture. So these are your manual pull stations. These will be located near exterior doors so that, if you notice an emergency and the alarms aren't going off, you can manually start the fire alarm. Or this will be, or this up here is the fire or smoke, heat, or CO2 sensor, and that will also start a fire alarm. Or start the alarm in the building. That will also start the alarm in the building to warn people to get out. And lastly, you have notification devices. That is this one right here. That is both. This one is an audio and visual. So this will have a loud alarm sound along with instructions, and this will flash. And this lets people know that there's an emergency going on and to exit the building. So once again, it's the fire alarm control panel, the initiating devices, so either one of these, and the notification device right here. So now let's take a look at the slides. These all come from the National Electric Code, or NEC. First, we have branch circuitry, or branch circuit. This is the circuit conductors between the final overcurrent device, protecting the circuit panel boards and the outlets. So that is, the branch circuit is anything after the panel boards to all of your different outlets, or if you have any equipment, it's basically, the last, it's the conductors going between the panel board and the device using the electricity. Next is a circuit breaker. That's a device designed to open and close a circuit by non-automatic means, and to open a circuit automatically by a predetermined overcurrent without damage to itself when properly applied within its rating. So what that means is that when it's talking about this automatic and non-automatic, so it closes by non-automatic means, which means you have to manually turn it on. And a closed circuit is one that is a complete circuit so that electricity runs. An open circuit means that there's a break in it, and that means there's no electricity running. So that's why it'll automatically open. So whenever the breaker trips, that's opening. Next is panel board. This is a single panel or a group of panel units designed for assembly in the form of a single panel designed to be placed in a cabinet or cutout box, placed in or against a wall, partition, or other support, and accessibly only from the front. Panel board houses circuit breakers. So this is what you see in your house, with the switches. If you overload a breaker, it'll pop and it'll open up, and you can't use that anymore until you reset it. Overcurrent, this is any current in excess of the rated current of equipment or the ampacity of a conductor. It may also result from overload, short circuit, or ground fault. So that is any time that more current is trying to be pulled than a breaker is rated for. So this one right here is rated for 20 amps. So a lot of household, or most household equipment is rated under 20 amps, so you can use these smaller breakers right here. If you load up a circuit too much, it'll pop and open up and flip the switch. A demand factor, this is a ratio of the maximum demand of a system to the total connected load of a system under consideration. Total possible load typically does not exceed 80% of the maximum. So you should only have up to 80% of this 20 amp utilized, so 16 amps is normally the max you can have on one circuit. Next is device. This is a unit of an electrical system that carries or controls electrical energy as its principal function. That is essentially anything you plug into the wall that uses electricity. That's going to be a device. Disconnecting means a device or group of devices or other means by which the conductors of a circuit can be disconnected from their source of supply. Important for maintenance of equipment. So we talked about this on the other slideshow. This is how you would turn off electricity to be able to work on a piece of equipment. Next is energized. This is electrically connected to or is a source of voltage. That is anything that has power running through it. Next we have feeder. This is all circuit conductors between the service equipment, the source of a separately derived system or other supply source, and the final branch circuit overcurrent device. So this is any wire that's going between, like, say, a main switchboard and a transformer or a smaller panel board. Next, we have outlet. That is a point on the wiring system at which current is taken to supply utilization equipment. So that's going to be any sort of receptacle, plug that's on your system. Next is ground fault circuit interrupter, or GFCI. This is a device intended for the protection of personnel that functions to de-energize a circuit or portion thereof within an established period of time when a current to ground exceeds the value established for a Class A device. So you'll see these usually in anywhere there's water. So in the kitchen, you'll have at least one of these. In the bathroom, outdoors, like your garage or your exterior outlets. So basically, if there's a water that gets in a plug, then it'll pop and it'll de-energize or turn off this plug. And in your bathroom, you could just have one outlet that's GFCI, but as long as the other outlets are connected downstream from the panel, then this one GFCI protects all of those outlets. Next is ground fault. This is unintentional electrically conducting connection between an ungrounded conductor of an electrical circuit and a normally non-current carrying conductor, metallic enclosure, metallic raceway, metallic equipment, or earth. So if you have a broken wire in a plug, and this is like a metal box, and it touches that metal box, it will energize this whole plug and can cause injury. You know, if you touch it, you could get shocked and get hurt. So ideally, you know, as soon as this broken wire touched a box, it would cause the overcurrent protection or the breaker to flip, turn electricity off to this device. So service equipment. This is a necessary equipment, usually consisting of a circuit breaker or switches and fuses and their accessories connected to the load end of service conductors to a building or other structure, and is tended to constitute the main control and cutoff of the supply of electricity. It's going to be any equipment after your electrical service and before your primary panel board. Next is voltage. This is a nominal value assigned to a circuit or system for the purpose of conveniently designating its voltage class. 120, 240, 480, 277, 600 are a couple examples. The actual voltage at which a circuit operates can vary from the nominal within a range that permits satisfactory operation of equipment. So that just means that like 480 volt equipment can run anywhere between 460 and 500 volts. It doesn't have to be stuck at a specific amp. It's an electromotive force or potential difference expressed in volts. A couple examples of voltages we commonly use: 120 volt, 208, 240 is residential, 277 and 480 are considered medium voltage, usually for larger buildings and larger pieces of equipment. Next, we have ampere or amp. Ampere is a unit of measure of the rate of electron flow or current in an electrical conductor. Ohm. Ohm is the standard unit of electrical resistance in the International System of Units. And voltamp, this is a unit used for the apparent power in an electrical circuit equal to the product of its root mean square RMS voltage and RMS current. So that is it for the electrical slides. There will be a quiz regarding some of these terms, and I will let you know. Thank you.